So now we want to be able to compare our population's variability between the two different sets of data. And it's really easy to do when they give you a picture. So I'll show you one with a picture, but sometimes they're not going to do that and they're just going to give you some numbers. And we still want to be able to compare how much the two different sets of data vary from one to the other. So how we do that is this little formula right here, the difference of the means divided by the MAD. In this, I'm generally going to tell you what the two means are, and I'm going to tell you what the MAD is, and I just want you to set it up and solve it. And then the only extra thing you have to do is you have to tell me how much they differ. So how much do they overlap, really? So here's just an example. You can see I subtracted the two means and then divided by the MAD and ended up with an answer of 2.5. So something for you to know is when you get a 0 as your answer, that means that they are completely overlapping, completely. Okay, so I always think 0 difference between the two sets of data. They overlap 100% because it's 0 difference. If you get like a 1 to 2, then this is when I would say they overlap a lot. Like most of the stuff is overlapping. There's a few points here or there that don't quite overlap. If you get a 3 or more, this is when I start to say it's a little. It overlaps a little. Generally that's when it's like a little less than 50% of it overlaps a little. And notice I'm saying plus, like it can go on and on. There's not exactly a set number where once it hits 10 or whatever, it's not overlapping at all. The only way you can say that it overlaps not at all is if they give you the data and you can tell. So if you see the pictures and you can see they're not overlapping, or they gave you all the numbers and they don't overlap. Otherwise, you have to stick with a little because there could be that one outlier that does make it overlap just barely, and it's kind of throwing the whole thing off. Okay, so let's practice. So I'm just going to tell you these numbers real quick. So the mean, because usually I would give them to you. So the mean for this first one is 85. The mean for the second one is 65. Okay, then we want to find the difference of those means. So we're going to do 85 minus 65, which gives us 20. And then we would take that number and divide by 6.25, divide by our MAD. So really I would initially set this up as 85 minus 65 over 6.25. I would step it out, get 20 over 6.25, and then simplify that. So 20, yes, you get a calculator, divided by 6.25, and we get 3.2. Okay, and then again, the extra thing I would want you to say is how much it overlaps. Here we would say it overlaps a little. And you can actually see that with our picture. It's overlapping a little. Not quite half of it, a little less than half, so that is a little. Okay, here's another one, but without any pictures. So we're going to do the difference of the means divided by the MAD. So 70 minus 50 divided by 5. Okay, I get 20 divided by 5. And when I solve that, I get 4. So 4 would be, again, a little. You can't tell for sure if it's none, but it's definitely not a lot or completely. And I'm just going to kind of show you this to help you visualize it a little better. Remember we talked about how the MAD is like how spread the data is from that mean. So here the range for A, for group A, is kind of like 45 to 55. And for group B, it's kind of like 65 to 75. Again, that doesn't mean all the data fits in there. That's just kind of generally, that's about how spread out the data is. So it looks like it won't overlap at all, but you don't know. There could be 1 or 2 little outliers that do make it overlap just barely. So we have to say a little since they didn't give us the exact data. All right, again, difference of the means divided by the MAD. So 100 minus 95 divided by 5, that gives me 5 over 5, which equals 1. We said 1 to 2 would be a lot. So we're going to go with a lot here. again, if I kind of show you that breakdown, this data set looks like it's going from about 95 to 105. This data set's going from about 90 to 100. So you can definitely see some overlap here with this one going all the way up to 100 and this one going all the way down to 95. Looks like that range of 95 to 100 is going to give you some good overlapping. Okay, so definitely a lot for that one. Okay, difference of the means. So 60 minus 60 divided by the MAD. 60 minus 60 gives me 0 over 4, which is equal to 0. Okay, and then 0, remember, means there's no difference. So here they are completely overlapping. They overlap completely. One more. So difference of our means, 70 minus 13 divided by the MAD. 70 minus 13 gives me 57 divided by 3. 57 divided by 3 is 19. Okay, 19 looks like probably not at all. And especially if we look here, it's going to be like from 67 to 73 and from 10 to 16. That looks like they shouldn't overlap. But again, we don't know. There could be an outlier in both of these, or a couple outliers in both of these sets of data where they just barely overlap. So we have to go with a little, even though most likely it's not at all. All right, finally, so what does this ratio tell you about how much it overlaps between the two distributions? Again, it's just kind of showing you how far apart the data is, how much overlap there is between the two sets of data.